right now?
I don't want it.
I don't either.
Maybe I should show that. All right.
What's in my left hand, bro?
Wait, can I see what? More delicious watermelon.
Scrumptious. Wonderful.
Okay, 23 says find the, wait a second, yeah, we're ready for 23. So find the area of the triangle. So we learned an area formula if they didn't give us like the height. And this is it. Okay, this works on, guys listen. I didn't say you could eat that, put it away. Okay, this stuff over here only has been working on right triangles. You guys notice that?
Yes.
Only on right triangles. But this area formula is actually for any triangle. Okay, and the way it works is you have two sides and you have to have like an angle in between them here, like angle C or whatever. Two sides and the angle between them. So little a, little b stand for the two sides, and capital C stands for the angle between them. You just plug it into that formula, and that's the area. So on 23, we got a bit of a problem because the two sides that it gives us, 5 and 4, it doesn't give us the angle in between those two sides. So how could we find the angle in between those two sides?
Add 41, 45, 55.
Okay, right, the angles have to add up to 180, so 180 minus those two should give us angle C. So 41 plus 55 is 96, so 180 minus 96 is 84. So we've got 5, 4, and 84. So we're just going to plug those in. So it's 1/2 times 4 times 5 times sine of 84.
9.9.
9.9 centimeters squared.
What about like 24?
Yeah, we're not doing 22. I updated a little bit. But 24 is, you do need to do it. So on 24, they don't give you any angles. What, Gracie?
Well, here's the size of the same. Could you split it in half and make it a
Okay, yeah, because it's an isosceles triangle, if you draw the altitude down there, it's going to split it, yeah.
So then you do a half.
It's going to split the bottom in half, so this would be like a 5 right there. Now, there's actually a couple ways you could do this.
Pythagorean theorem to find height.
You could use Pythagorean theorem to find the height of the triangle, do base times height divided by 2, or we could find this angle right here and use that formula. Because once you have an angle, you do side times sine of the angle divided by 2. How could we find this angle? Well, relative to this angle, what two sides do I know in this little right triangle here? 5 and 13 are the what? Relative to this angle. Angle Z. Adjacent and hypotenuse, which is the cosine of the angle equals adjacent over hypotenuse. How do we go backwards to find the angle here? Cosine inverse. Okay, so now we've got an angle, and we have the two sides around the angle. Let's say 67.4. We've we've got an angle and the two sides around the angle.
So you just do 13 and 13 times the angle and like half.
Although, wait, would you not have to use the half because that's from,
Well,
oh wait, no, never mind.
no, I changed it back to a 10. Like the full triangle.
Do we have to put the thing
I
sine
got 60.
Do what?
Passing
in the
out of the way.
in the column do
1/2.
times 13 times 13 times 164.
Yeah. Yep.
Yeah.
Okay. Number 25, it says express each vector in component form. So component form means like how far does it go in the x direction, how far does it go in the y direction, like with the parentheses and that kind of thing. That's what they mean by component form. You guys see vector u in the picture on the right? How far is vector u moving in the x direction?
2,
Positive 2. How far is it moving in the y direction?
2.
2. So the component form for vector u is 2, 2. Yeah, very funny.
Do you think that's where I'm thinking?
No, that's slow. Okay, for 27, it says describe the vector by stating its magnitude and direction. You guys remember what magnitude meant? Length. How long was the vector? So how do we know how long that vector is? Yeah, we just said the vector goes 2 to the right and 2 up, right? So it's 2 and 2. So that makes a little, if you draw it in there, that makes a little right triangle, and we can use Pythagorean theorem to find out the vector. So 2 squared plus 2 squared equals c squared. 4 plus 4. Okay, it did not tell us that whether to use a decimal or a radical in the directions. So you can put a decimal if you want to, but if you use the radical, you have to simplify square root of 8. Because what goes in the square root of 8? What goes into 8? It's 2 square root of 2. So that's the magnitude. You guys remember what we put when they asked for the direction on these problems? Yeah, like how many degrees is this line, is this vector above the x-axis basically? So how can I find that little angle right there, theta? Yeah, some of you might notice it's a 2 by 2 right triangle,
45.
so it's going at a perfect diagonal, 45-degree angle. Let's pretend we didn't know. How could we use trig to find this angle? Because we're going to have to do that in the next problem. Opposite and adjacent is tangent of theta equals opposite over adjacent. So it's tangent inverse of 2 over 2, or tangent inverse of 1.
45.
45, what a shock. 45, so the way the book wrote this, I don't think I made you guys write it quite like this. It's 45 degrees above the x-axis, the positive x-axis, I guess, because it's going to the right. I'll probably just accept 45 degrees. All right, 29, I think 29 is the same kind, right? I like it. Okay, it's vector u plus vector v. So basically what's happening, let's get rid of this, let's get away there. Vector u is is going to the right and 2 up. It kind of looks like that. And then vector v is going like 2 to the left and 6 up. And if you add them together, so it looks kind of like that. If you add them together, or no, 2 to the left and 4 up, right? Isn't that what vector v is doing? If you add them together, you get a vector that looks like this, basically. So it's going like straight up. Here's another way to think about it. This one's going over 2, up 2. This one's going, how far is this one going in the vector v? Going in the x direction? Negative 2. 4. If you add those 2 vectors together, it's just like adding these together. You add the x's together, add the y's together. So what's negative 2 plus 2? 0. What's 4 plus 2? 6. So this vector that they create together would be like 0, 6. It's kind of like their forces in the x direction cancel out, because it's going left and right. But their forces in the upward direction get added together to go up 6. All right. Wait, was that all they asked on 29? Yeah. 31 is v, vector v minus 2 vector u's. So vector v, we just kind of talked about it, it's right there. It's negative 2, 4. Minus 2 vector u's, which we said was 2, 2.
So 4 and 4.
Right. If you double vector u, it becomes 4, 4.
So the negative 2 minus 4.
So yeah, we have negative 2 minus 4.
Negative 6.
And we have 4 minus 4. 0. Any questions on that one? Vector v, vector u. Okay, 33. Express each vector in component form, kind of what we're doing. Round answers to the 10th place. 15 miles southeast. Okay, you guys know your compass directions on the map. Where's southeast at?
Wait,
Okay,
which
now-
way am I facing?
Not on,
Right.
not in real life. We're talking about,
Oh, it'd be like that.
yeah,
Pointing right down. Wait.
north, east,
In the.
South.
Never eat slimy.
What is
you guys see that one? Get that?
What side is that?
Oh. I never eat sour.
Never eat
Yeah, never eat salad or water. Okay, so if you're going directly southeast, you're going at a perfect diagonal in this direction. Okay, we need this in component form, like how far right and how far down are we moving, like that. What angle would this have to be right here?
45.
Why is it 45? Well,
Because it's going.
because it's halfway to 90, right? Half of 90 is 45.
So that means whatever it is, it's going, x and y are going to be the same. So
Okay, let's use, there is a way to do this with special triangles. You guys remember the 45, 45, 90? I don't have a lot of faith in your special triangle abilities, so let's try trigonometry instead. Relative to this angle, what side are we looking for right here? What side is that called? Adjacent. And we have the hypotenuse. They told us we're going 15 miles southeast, so that's where the 15 came from. So which trig function uses adjacent and hypotenuse? Cosine. So cosine of 45 equals adjacent over hypotenuse. And how do I solve that with the calculator? Cosine of 45 times 15.
I found it a different way.
we're rounding to the 10th. If you know special triangles, you could do 15 divided by square root of 2. Is that what you did, Will? Did you do 15 divided by
I
square root?
squared 15, then divide that by 2, then square root of that. I got the
Clever.
same answer, but I did.
Clever. All right.
I also plugged it in this way too.
What'd you guys get?
10.6.
I got,
I think it is 10.6. You not get that?
well, I got it just the,
Oh, well, yeah, this one they do want a decimal on this one. Okay, I'm not gonna be picky. If you put a decimal or a square root on these, it's gonna be okay. Rounds to 10.6. So 10.6 to the right, whoops. And then, well, how far down is it gonna go? You could do sine of 45 equals y of 15 to kind of repeat the process. But since this is a perfect diagonal, perfect 45-degree angle, it's got to go over and down the same amount. So what would my y value be? Negative 10.6, good. The other class did not get the negative part right. So it's 10.6 because we're going to the right, negative 10.6 because we're going down.
I'm such a slave.
Hmm?
I'm such a slave.
I know. Thank you for gracing us with your presence.
No, my head is so low.
It's embarrassing. It's like a 91.
That's so embarrassing. Yeah, it's not embarrassing, but like
It's pretty embarrassing. I feel embarrassed for it.
it's dangerously like. It's dangerously low.
Your third quarter grade was better, so.
Yeah, I know.
All right, 35. Oh, number 34. State the Pythagorean identity and state three forms of the Pythagorean identity. Anybody remember the Pythagorean identity? I probably said that word like once. Okay, this is like an exact problem we did from the homework. This is the like original Pythagorean identity, sine squared plus cosine squared equals 1. How do we state it in three forms though? No. This is it right here. Like a squared plus b squared equals c squared is sine squared plus cosine squared equals 1.
Cos squared x equals 1 minus sin
Okay,
squared x.
yeah.
And then vice versa.
If you subtract cosine squared on both sides, you get sine squared equals 1 minus cosine squared. Right? Or if you subtract sine squared on both sides, you get cosine squared equals 1 minus sine squared. So those are like three different ways to write it. It's just the same thing rearranged. So this is one way to write it, and then the other two ways are like if you subtract cosine squared to the other side, or if you subtract sine squared to the other side. 34 was like identical to a question they asked us on the homework for that assignment. 35. Okay, express each trig ratio. So I told you guys, like, I'm going to make SOHCAHTOA number 1 on the test, which means you're going to have to write this stuff. All three of these, no, right here, just the SOHCAHTOA, not this. So you're going to have to be able to write this on your own or get the problem wrong. And then after you do that, I'm going to, like, after I grade it, I'm going to write this on the board if you got it. So if you got anything wrong, you can, like, fix it. And then do the rest of the problems. But I'll leave this up here too.
Thank you.
So this is the only thing that SOHCAHTOA is the only thing you have to have memorized. Not just the word SOHCAHTOA, but what it means. Like, so means all this, ka means all this, toa means all that. And the rest of this stuff I'm not gonna have you memorize. So you just need that one. We'll just leave that on the board. I forgot what we're doing. Oh yeah, something with that stuff. Okay, it says secant of b.
Hypotenuse over adjacent.
Alright, the first thing they want us to do is write it as Secant is the reciprocal of which function?
Hypotenuse and
Cosine. So the first thing they want us to do is write 1 over cosine. The second thing they asked us to do in the directions is to write it as a ratio of the sides of that triangle that they gave us. So cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So on that triangle in the picture, we need hypotenuse and adjacent. So what's relative to angle B? What's the hypotenuse?
C.
What's adjacent to angle B? A. So yeah, it's just C over A. That's all they, so there's kind of two answers, those two things. That's all they wanted.
Oh, so like,
37 is another one. So on 37, we're supposed to do cosecant of B. Cosecant is the same thing as, or is the reciprocal of sine. Sine is opposite over hypotenuse, so cosecant is hypotenuse over opposite. So relative to angle B, what's the hypotenuse? C. What's the opposite? B. So this would be equal to C over B. Yes. 38 through 40 is everybody's favorite problems. I'll just probably make the test solely out of these kinds. Just for Jaden's sake. Secant x over cosecant x. So we're supposed to read it. Alright, what's secant the same thing as?
Cosine.
1 over cosine.
Cosine.
What's whoops, this is supposed to be cosecant. I wrote it wrong. What's cosecant the same thing as?
1 over
Cosine.
sine.
1 over sine. How do we divide fractions? No.
Oh, and then
Cross.
Right. Like if I was doing 3/4 divided by whatever, 5/7.
You flip the second one?
You do, yes, you do 3/4 times 7/5, right? And then multiply top and bottom. So this is 1 over cosine times, flip this one, sine over 1. And what do you get when you multiply these two together?
Sine over cos.
Sine over
which
cosine.
doesn't that equal- Yep.
Which equals
tangent.
tangent. I guess I'll put it down here. I'll put the x back in there. That's what we're trying to get to. Sine times cosecant minus sine. Okay, there's more than one way to do this. I'm gonna try to do it the easiest way though. What kind of problem does this look like? Distributed problem, yeah, that's basically what it is. First I'm gonna start with, what does cosecant change into? 1 over sine. So let's just say this is sine times 1 over sine minus sine. Okay, now let's go ahead and distribute. What is sine times 1 over sine? No,
Sine over sine, 1.
1. 1, yeah, the signs cancel out. So sine times 1 over sine is 1. And what's sine times sine?
Sine squared.
Sine squared. what's 1 minus sine squared? Cosine squared. If you subtract sine squared, 1 minus sine squared is just cosine squared. Put the x back in. Nothing. That's okay, I'll put one on there. Secant minus. Thursday we'll talk about, I'll make up a problem that's really close to the one on the test. That's right.
On 40, would you turn the second into 1 over cos?
Secant cosine, yeah. Secant is 1 over cosine, yes. This one's probably the trickiest, of course they saved it for last. When you're adding and subtracting, why are your eyes dilated or something? Why are you wearing those?
It's really bright.
Is that no reason, basically? Take your glasses off.
He told me they were
I mean, if your eyes are dilated, that's one thing, but otherwise,
You just told me.
too much light is a vampire.
Yep.
Okay. What, when we're adding and subtracting fractions, what do we always need to have? Common denominator. What's the common denominator gonna need to be between 1 and cosine here? Cosine.
So you multiply cosine by
Right.
1.
You multiply
Or
this by cosine to turn it into cosine. Anything you do on the bottom, you have to do on the top. So this becomes, what's cosine times cosine? And then this is just cosine. Okay. Now that they're the same denominators, you can just put them together. It's 1 minus cosine squared. Remember, when you add and subtract fractions, the denominator does not change. Yeah. Should make you actually go like get a 6th grade book and make you guys do some of these problems every now and again. Without a calculator.
No, but torture.
The 6th grade book?
I forget.
Like multiplying fractions, long division.
Oh, I can't do long division anymore either. I tried to help, like, one of the fifth graders, I didn't know how to do it. I got it wrong. It's like,
I had to use long division on trigonometry.
I got the long division wrong, so I do the calculator somewhere.
I tried using long
Okay,
division on trigonometry.
This right here, 1 minus cosine squared, that should ring a little bell because we just talked about something like that. What's 1 minus cosine squared equal to?
sine squared.
Sine squared.
No.
So this just becomes sine squared over cosine, which is not quite what we were going for. What we were going for
We need to.
is, did they say sine times tangent, I think?
Yeah.
Is that what they said? Okay, this looks a lot like tangent, but what's wrong with it?
It's
2 sine.
Yeah, there's 2 sines.
So,
So I'm gonna,
would it just be like 1 sine?
well, I'm gonna separate the top there.
It's like a mental illness when you're just staring at it.
So then the sine of cos would equal tangent.
No, I was just overwhelmed with all of this.
Don't panic, Marion, this is,
I don't know where my notes are though, that's why I can't do anything.
all the notes you need are like right
No,
here.
she has more. She didn't study hall. She has so much of that work. It's the end of the notes, but that's why I
Yes,
have to
I'm done. Guys, make sure and work on those even so I can, if you get stuck, I can